Hello everyone, welcome to our daily physics problem, day 18. So today we are going to look at a hand stick with length L, mass m1, with a block with mass m2 on its left end and with two ropes attached to the wall with angle theta and angle phi. What is the distance between the block and the center of mass of the stick block system? So I want you to try to pause the video, try your own. After you try it, come back to the video, then I will show you how I did it. So welcome back guys. So today we are going to show one solution to the problem. Actually, we're going to show two total. We'll show one tomorrow. Today, one tomorrow. So today we're going to look at the classic solution. And tomorrow we're going to show you a trickier solution. It's much more simple, but it's very elegant, and you can use that trick to solve other problems, especially on two-dimensional three-force system. So let's first have a look. Let's lay all the forces here. Let's assume this point as the center of mass of both block and stick. We have gravitational force, distance will be x, total distance is L, and we have two tension force, T1 and T2. Then let's balance the force. First, in the horizontal direction, we have T2 times sine theta equal to T1 times sine phi, because there's only two forces, one left, one right. Then in the vertical direction, we have T2 times cosine theta plus T1 times cosine phi will equal to m1 plus m2 times g. Then as for the torque, let's define our pivot point as the left side of the stick. Because T2 and m2 are acting on the point, so we just ignore them. So when we have the m1 times g times x is the lever arm times is equal to T1 times cosine theta phi times L. That will be the other force. Then we can try to solve our system equation. For that, actually we are just solving for x because we want to know distance. So we know x is equal to T1 times cosine phi times L divided by m1g. But we don't know T1. Other thing we already know. So all we need to do is solve for T1. So let's look at the horizontal vertical equation to solve for T1. We know T2 is equal to T1 times sine phi divided by sine theta from the horizontal equation. Then let's plug into the vertical equation. We have T1 times sine theta times cotangent theta plus T1 times cosine phi equal to m1 plus mg times g. So now we solve for T1, factor out the T1, we have T1 times cosine phi cotangent theta plus cosine phi is equal to m1 plus m2 times g. Then we know T1 is equal to m2 plus m1 times g divided by sine phi cotangent theta plus cosine phi. Then let's plug it back into our equation. Let's just replace T1 by this expression. We'll all cancel out some terms. G cancel out. And then let's multiply both sides of the fraction by sine theta. Why would I do that? Oh, because you'll see. We'll simplify our equation. Multiply by sine phi. Cotangent theta divided by sine theta, just cosine theta. Then this is sine phi theta, this is sine theta. Then we have L times m1 plus m2 times sine theta times cosine phi divided by m1 times sine phi times cosine theta plus cosine phi times sine theta. Well, if you know our trigonometric identity, you know that sine phi plus cosine theta plus cosine phi times sine theta is just equal to sine phi plus theta, because it's our angle addition identity for sine. So it's equal to sine phi plus theta. And that will be our final solution here. So tomorrow we are going to look at a much simpler way to solve the problem. But before that, we need to prove a theorem. So tomorrow we're going to prove a theorem and show a more simpler way. See you tomorrow.